Tonight, we're going to explore one of the most astonishing ideas in all of modern science, a claim made not by some fringe dreamer, but by one of the most brilliant physicists who has ever lived, a man who won the Nobel Prize. His name is Sir Roger Penrose, and he believes something that sounds, when you first hear it, almost impossible. He believes that the Big Bang was not the beginning of the universe. Sit with that for a moment because it cuts against everything most of us were ever taught. For as long as any of us can remember, we've been told a simple, powerful story. In the beginning, there was the Big Bang. Everything that exists, every star, every galaxy, every atom in your body, and space and time themselves burst into being in that single moment around 14 billion years ago. And before it, nothing. Not empty space waiting to be filled, not darkness, not even time ticking away in an empty void, nothing at all. The Big Bang, in the usual telling, was the first event, the start of the clock, the edge of reality, beyond which there is simply no further back to go. But Roger Penrose looks at that story and says it is unfinished. He says the Big Bang was not the beginning. He says something came before it, and not just a little something. He says an entire universe came before ours. A complete cosmos with its own stars and galaxies, and perhaps its own quiet worlds that lived out its whole vast existence and died long before our universe was ever born. And he says that our universe, in its turn, will one day give birth to another. An endless chain of universes, each one rising out of the death of the one before it, stretching infinitely into the past and infinitely into the future. No first beginning, no final end, just cycle after cycle after cycle, forever. It is a staggering thing to propose, and the most remarkable part is that Penrose isn't merely daydreaming. He has built this idea out of real physics and real mathematics, and he even believes he has found faint fingerprints of that previous universe written across the sky above us in the oldest light there is. Now, I want to be honest with you from the very start. Most scientists are not convinced. This is a bold and controversial idea on the edge of what we can test, and we'll treat it with that honesty all the way through. But the idea itself is one of the most beautiful and profound that any human being has ever dared to think. And by the end of tonight, you're going to understand exactly how a universe could reach its end, and in that very same ending, quietly begin again. Before we drift all the way back to the beginning of time, if these slow journeys through the cosmos help settle your mind, at the end of the day, take a moment to subscribe and come along. It's a small thing, but it helps these quiet explorations reach the others out there, lying awake right now, wondering about the same vast questions you are. Now let's begin. To understand why Penrose's idea is so radical, we first have to understand the story it's challenging, the standard picture of the Big Bang, the one written in the textbooks, the one almost every scientist accepts. Because it's a magnificent story in its own right, and it's worth telling gently before we complicate it. A little over a century ago, we didn't even know the universe had a beginning. Many of the greatest minds, including Einstein himself for a time, assumed the universe was eternal and unchanging, that it had simply always been here, more or less as we see it, stretching back forever. It was a comfortable idea, a universe with no birth and no death. But then the evidence began to arrive, and it told a very different story. Astronomers discovered that the galaxies are flying apart. Everywhere we look, in every direction, the distant galaxies are rushing away from us and from each other. The whole universe is expanding, growing larger with every passing moment, like a vast loaf of bread rising in an oven, every raisin drifting away from every other. And if the universe is expanding now, if everything is rushing apart, then it follows that long ago everything must have been closer together. Run the film backward, and the galaxies draw nearer and nearer. The universe grows smaller and hotter and denser until you arrive at a single moment around 14 billion years ago, when everything we can see was packed into an unimaginably small, unimaginably hot point. And from that point, it all began to expand. That is the Big Bang. It's one of the great triumphs of human thought that we can say this at all, that we can look out at the night sky and reconstruct the birth of everything. And the evidence for it is overwhelming. We can still see the faint afterglow of that early heat, a whisper of radiation filling the entire sky, left over from when the young universe first cooled enough to become clear. We can measure how the galaxies are flying apart. We can calculate how the first simple atoms formed in the furnace of those opening minutes. The Big Bang, as the description of how our universe expanded and cooled and grew, is about as solid as science gets. But there has always been one question lurking underneath it all, a question that children ask, and that the greatest physicists have never been able to fully answer. If the Big Bang was the beginning, then what came before it? What was there before the bang? What lit the fuse? And here is where the standard story gives an answer that is honest, but deeply unsatisfying. The usual reply is that the question itself doesn't quite make sense, because in the standard picture, time itself began at the Big Bang. Space began. The Big Bang wasn't an explosion that happened inside an existing space with an empty stage waiting around it. It was the beginning of the stage itself, the beginning of space, the beginning of time, the beginning of before and after. So asking what came before the Big Bang in this view is a little like standing at the North Pole and asking which way is north. There is no further north to point to. You've reached the place where the question runs out. There was no before, because before is a thing that only exists once time has started. The beginning was, quite simply, the beginning. For most cosmologists, that is where the matter rests. The Big Bang is the edge of everything, a boundary we cannot see past, perhaps cannot ever see past, and we make our peace with it. It's a strange and humbling thought that reality might just have an edge, a first page with nothing behind it. But not everyone has made their peace with it, and one of those who refused to is a man whose brilliance is almost impossible to overstate. His name is Roger Penrose, and before we go any further into his strange and beautiful idea, you should understand who he is, because it matters. This is not a crank with a wild theory shouted from the sidelines. Roger Penrose is one of the towering figures of modern physics, a British mathematician and physicist who has spent more than 60 years at the absolute frontier of our understanding of space, time, and gravity. Back in the 1960s, working sometimes alongside a young Stephen Hawking, Penrose proved something profound about black holes. He showed, with pure mathematics, that when a large enough star collapses, the formation of a black hole and the singularity hidden at its heart, a point where space and time themselves break down, is not just possible, but unavoidable. It's woven right into the equations of Einstein's general relativity. That single piece of work is still regarded as one of the most important contributions to our understanding of gravity since Einstein himself. And in the year 2020, Roger Penrose was awarded the Nobel Prize in Physics for exactly that achievement, for showing that black hole formation is a robust prediction of general relativity. So when this particular man tells us that he thinks the Big Bang was not the beginning, it is worth slowing down and listening very carefully. He has earned that much. Now, it's important to be precise. His Nobel Prize was for his black hole work, not for the cosmic cycle idea we're about to explore. The cyclic universe is his bolder, more speculative vision, one that most of his colleagues do not accept. But it flows from the same deep, lifelong obsession. The nature of space, time, and the strange places where they begin and end. And to follow him into it, we have to take a journey all the way to the end of time. Because Penrose's idea begins, strangely enough, not at the beginning, but at the end. To understand how he thinks a new universe is born, we first have to understand how he thinks our universe will die. So let's travel forward, far, far forward, into the deepest future of the cosmos, and watch, in slow motion, as everything we know fades away. Right now, we live in a bright and busy age of the universe. The sky is full of stars. Galaxies blaze with the light of hundreds of billions of suns. New stars are being born in great clouds of gas, even as old ones die. It feels permanent. It feels like the natural, eternal state of things. But it isn't. We are living in the universe's brief, glorious morning, and that morning will not last. The first thing to understand is that the universe is running out of the material to make new stars. Stars are born from clouds of gas, and every time a star forms, some of that gas is locked away forever. Slowly, across enormous spans of time, the universe is using up its supply. Star formation will wind down, and then, eventually, it will stop. The last star will be born. And after that, no more will ever ignite. The universe will be left with only the stars that already exist, slowly burning through the last of their fuel, and stars, one by one, die. Our own sun has about 5 billion years left before it swells, sheds its outer layers, and fades into a slowly cooling ember. The smallest, dimmest stars, the red dwarfs, burn so slowly and so frugally that they can last for trillions of years, far longer than the universe has so far existed. But even they will eventually flicker out. And so, across a span of time so vast it dwarfs the entire history of the universe up to now, the lights will go out one by one. The galaxies will dim. The great blaze of starlight that fills our sky today will fade to a deep and reddening gloom, and then to darkness. There will come a time when the last star dies and the universe goes truly dark, a cold, black expanse scattered with the cooling corpses of dead stars drifting in an ever-growing emptiness. But even that is not the end. Because the universe keeps expanding and over unimaginable stretches of time, even matter itself does not last. The dead stars, the burnt-out cinders, the cold planets, over time scales that make 1,000,000,000,000 years look like an instant, much of this matter is drawn together by gravity or torn apart, and a great deal of it ends up falling into black holes. Black holes become the dominant feature of the aging cosmos, vast, dark, silent giants, having swallowed the remains of galaxies sitting in the deepening dark. And here is where it gets truly strange and truly important for our story. Because black holes, it turns out, are not eternal either. Thanks to the work of Stephen Hawking, we believe that black holes very, very slowly evaporate. They leak away their energy, particle by particle, in an almost unimaginably faint glow, and over time, they shrink. The bigger the black hole, the longer it takes. And the supermassive black holes at the centers of galaxies would take something like 10 to the power of 100 years to fully disappear. That is a 1 followed by 100 zeros, a number so large that calling it astronomical is an insult to how large it truly is. The entire age of our universe so far, 14 billion years, is nothing, less than nothing, against a span like that. But time in this deep future is something the universe has in endless supply, and so, eventually, even the black holes evaporate. The last of them flickers away in a final, faint wisp of radiation. And then the universe is, at last, truly empty. No stars, no planets, no black holes, no matter of any kind worth speaking of, just an unthinkably vast, cold, dark, endlessly expanding space containing almost nothing but the faint, dying glow of radiation, photons, particles of light drifting through the eternal dark, growing ever fainter, ever more spread out, forever. This is what physicists call the heat death of the universe, the final state, the last, cold, quiet chapter where nothing ever happens again and nothing ever changes for all of eternity. It is, by any ordinary measure, the bleakest ending imaginable, the complete and final triumph of cold and emptiness and silence. And it is precisely here, at this most hopeless and final of endings, that Roger Penrose does something extraordinary. He looks at this dead, empty, light-filled universe, and he sees a Big Bang. To understand how, we need to follow one strange and beautiful chain of reasoning, and it starts with a simple question that sounds almost childish, but turns out to be profound. In that final, empty universe with nothing left but light, how big is it? How much time is passing? And the astonishing answer Penrose gives is, there's no longer any way to tell. And not just no way for us to tell, there is genuinely no fact of the matter at all. Here's why. Think about what it takes to measure size or to measure time. To say how big something is, you need a ruler. some object of a known size to compare against. To say how much time has passed, you need a clock, something that ticks, that changes in a regular rhythm you can count. And here is the deep thing. Every ruler, every clock, every measuring device that has ever existed is built out of particles that have mass. Mass is what makes a clock tick. The most precise clocks we have are built on the natural rhythms of massive particles. Without mass, there is nothing to tick, nothing to hold a steady size, nothing to measure anything against at all. Now look again at that final universe. All the matter is gone. The particles with mass, the protons, the electrons, the atoms, have long since decayed or been swallowed and evaporated away. What's left is almost entirely photons, light, and light is massless. A particle of light has no mass at all, and because of that, something extraordinary is true about it. A photon does not experience time. This is a real and well-tested consequence of Einstein's relativity. Anything traveling at the speed of light, which is exactly what light does, experiences no passage of time whatsoever. For a photon, the moment it is created and the moment it is absorbed, even if they are billions of years apart, from our point of view, are the same instant. Light does not age. Light does not tick. Light feels no time. So imagine a universe with nothing in it but light. There are no massive particles left to act as clocks, so time has nothing to tick it forward. There is no longer any meaningful sense in which time is passing, and there are no rulers left to measure distance, so size has lost its meaning too. The universe is unimaginably enormous, yes, by our standards, but there is no longer anything inside it that can tell enormous from tiny. Without mass, without clocks, without rulers, the very concepts of big and small, of a long time and an instant, simply stop applying. The universe, in its final state of pure light, has forgotten how to measure itself. It has lost all sense of scale. And that is the hinge on which Penrose's whole vision turns. Because if size has genuinely lost all meaning, then there is no real difference between that final universe, vast, cold, and full of light, and a universe that is unimaginably tiny, hot, and dense. Our intuition screams that these are opposites. One is the emptiest, most spread out thing imaginable. The other is everything crushed into a pinpoint. But that intuition is built on the idea that size is real and fixed. Strip away every ruler, every clock, every massive particle that could tell the difference, and the two states become, mathematically, the very same thing. The cold, empty, light-filled end of the universe and the hot, dense, light-filled beginning of a universe are, when scale no longer exists, identical. This is the mathematical heart of Penrose's theory, and it has a name. He calls it conformal cyclic cosmology. The word conformal refers to a special kind of mathematical transformation, one that can stretch or shrink things to any size while perfectly preserving their shapes and their angles, the way a map can show a country at any scale without changing its outline. Penrose's insight is that when you only have massless light to deal with, The laws of physics don't care about size at all. They are, in the mathematician's word, conformally invariant. They work exactly the same whether everything is enormous or minuscule. And that means you are mathematically allowed to take that infinite, frozen, light-filled end of one universe and simply rescale it, shrink it down, and when you do, it joins smoothly and seamlessly onto the hot, dense beginning of a brand new one. The end of one universe doesn't just resemble the birth of the next. In Penrose's mathematics, it connects to it. It becomes it. The final moment of the old cosmos and the first moment of the new one are the same surface, the same boundary, crossed without a gap. What was the desolate, eternal heat, death from the inside becomes, from the other side, the brilliant, fiery dawn of everything. The death and the birth are not two events. They are one event seen from two directions. Penrose calls each of these complete universes an eon. Our universe is one eon. Before it came another, which lived its own 14 billion year morning and its own unimaginably long dark evening, and then died into the Big Bang that started ours. And after our eon ends, in that almost incomprehensibly distant future, our own heat death will become the Big Bang of the next eon, a whole new universe with its own stars and galaxies, born from the cold ashes of ours. And on, and on, and on. An infinite succession of eons, each one a full and complete universe, each governed by the very same laws of physics, each beginning in fire and ending in cold and light, and each cold ending feeding the next fiery beginning. A cosmos with no first page and no last, forever. Now there's one very important thing to be clear about, because it's easy to misunderstand. This is not a universe that expands and then collapses back in on itself, crunching down and bouncing into a new bang. That's a different idea entirely, one you may have heard of, and it's not what Penrose is proposing. In his picture, the universe never stops expanding. It expands forever, growing colder and emptier without end. There is no great collapse, no crunch, no rebound. The cycle doesn't come from the universe falling back together. It comes from that endless expansion carrying the universe to a state so empty and so scale-free that it becomes all over again indistinguishable from a beginning. The universe doesn't loop back. It expands so completely that its ending wraps around and becomes a beginning, not by returning, but by forgetting. It's a far stranger and more subtle idea than a simple bounce, the universe expanding its way into a new birth, rather than collapsing into one. Now, a beautiful idea is one thing, but science asks for more than beauty. It asks, is there any way to actually test this? Is there any evidence? And this is where Penrose's theory makes a daring move, because he claims that, yes, there might be. He claims that if his idea is right, the previous universe should have left faint marks on ours, and he believes he can see them. To understand where he's looking, you need to know about the oldest light in the universe. Cast your mind back to the early universe, just after the Big Bang. For the first few 100,000 years, the cosmos was so hot and dense that it was opaque, a glowing fog so thick that light couldn't travel freely through it. But as the universe expanded and cooled, there came a moment, about 380,000 years in, when it finally became transparent and light was set free to travel across space. That light has been traveling ever since for nearly 14 billion years, stretching and cooling along the way, until today it reaches us as a faint glow of microwaves coming from every direction in the sky. We call it the cosmic microwave background. It is the afterglow of the Big Bang, the oldest light there is, a baby photograph of the entire universe. And encoded in its faint patterns is a map of what the cosmos was like at the very dawn of time. Penrose's claim is this: if a previous universe really did exist before ours, then dramatic events in that universe, in particular the colossal collisions and final evaporations of its supermassive black holes, would have sent ripples of energy across the boundary between the aeons. And those ripples, he argues, should show up in our cosmic microwave background as faint, distinctive patterns, gentle concentric rings, or warm spots scattered across the sky. He has given the most striking of these a name. He calls them Hawking points, places where, he believes, we are seeing the dying flash of a giant black hole from the universe that came before ours, its entire lifetime of radiation arriving to us, smeared into a single point in the sky. If he's right, then when you look up at certain spots in that ancient light, you are looking at the ghost of a black hole from a previous cosmos, a relic of a universe that died before ours was born. It is a breathtaking claim, and I have to be completely honest with you about how the scientific community has received it, with deep skepticism. Most cosmologists are not convinced. When Penrose and his colleagues pointed to these patterns in the data, other scientists went back and checked, and they argued that the patterns are not really there in any meaningful way, that what Penrose sees as signals from a previous universe are, statistically, just the kind of random fluctuations you would expect to find by chance in any noisy data. Some of the most respected names in cosmology have pushed back hard, arguing that the leading theory of the early universe, called inflation, explains the cosmic microwave background extremely well, without needing any previous eon at all. As things stand today, conformal cyclic cosmology is very much a minority view, a bold idea on the fringes, not something written into the textbooks. There is no widely accepted evidence that it is true, and it's important to hold both of those things at once, without flinching from either. On one hand, this is a real, serious, mathematically detailed proposal from one of the greatest physicists of our age. On the other hand, it is unproven, contested, and quite possibly wrong. Both things are true. That's not a weakness in the story. It's just what the frontier of knowledge actually looks like, up close. Out here, at the very edge of what we can know, certainty is rare, and the most profound questions are often the ones we cannot yet answer. So tonight, we're not here to be told what is true. We're here to wonder. And there is no shame and a great deal of beauty in wondering about something we cannot yet prove. It helps to understand what problem Penrose was actually trying to solve, because he didn't dream up this idea for fun. He was wrestling with one of the deepest and most overlooked mysteries in all of physics, a puzzle about why the Big Bang was so strangely, suspiciously perfect. And to feel the weight of it, we need to talk about order and disorder and the one law of physics that may be the most unbreakable of them all. There is a principle in nature called the second law of thermodynamics, and in plain terms, it says this: things fall apart. Disorder always increases. Left to themselves, ordered things become messy. Concentrated things spread out. Differences smooth away. A hot cup of coffee cools to room temperature and never spontaneously heats back up. A sandcastle crumbles into a flat beach, never the reverse. A room gets messier over time unless you put work in. Physicists measure this disorder with a quantity called entropy, and the second law says that the total entropy of the universe is always increasing. Order runs downhill into disorder and never back up. This, in fact, is part of why time seems to flow in one direction at all. The past is more ordered, the future more disordered, and that difference is what gives time its arrow. But here is the puzzle that haunted Penrose. If disorder always increases and has been increasing for the entire history of the universe, then the universe must have started in a state of extraordinarily low disorder, extraordinarily high order. In fact, for the universe to have run downhill toward disorder for 14 billion years and still have all the rich structure we see, the Big Bang must have been one of the most perfectly ordered, smooth, special states imaginable, almost unbelievably so. The odds of a beginning that ordered arising by pure chance are so staggeringly, ludicrously small that the number can barely be written down. And no one knows why. Why did the universe begin in such an exquisitely special, low-entropy, ordered state? Why was the Big Bang so smooth and so perfect, when by all rights it should have been a chaotic mess? This is one of the genuine deep mysteries of cosmology, and most of the time we simply shrug and say, that's just how it started. An unexplained, miraculous coincidence at the dawn of everything. Penrose refused to shrug, and his cyclic cosmology is, at its heart, an attempt to explain that miracle, to answer the question of why the Big Bang was so special. Because in his picture, the smooth, ordered, low-entropy state of our Big Bang isn't a coincidence at all. It's inherited. It comes directly from the previous ion, specifically from the extreme, spread out, smoothed over state of that universe's heat death. Remember, the end of an aeon is a vast, uniform, featureless expanse of thinly scattered light, about as smooth and even as anything can be. And when that smooth ending becomes, through the conformal transition, the beginning of the next universe, it passes its smoothness along. The new Big Bang is perfectly ordered because it was born from the perfectly smoothed out death of the universe before it. The special beginning isn't a miracle, it's a hand-me-down. Whether or not Penrose is right, you have to admire the ambition of it. He took one of the most stubborn, unexplained facts about our universe, the strange perfection of its beginning, and tried to explain it, not by appealing to luck or to something beyond physics, but by connecting our beginning to another universe's end. He tried to make the miracle ordinary. That is what the very best physics does. It takes something we'd written off as a brute, unexplainable fact and reveals it as the natural consequence of something deeper. It's worth pausing here to realize that Penrose is reaching for something very old. The idea of a universe that cycles endlessly, with no true beginning and no true end, is not new at all. In fact, it may be one of the oldest ideas humanity has ever had. Long before telescopes, long before equations, people looked at the world around them and saw cycles everywhere. Day followed night, followed day. The seasons turned, winter into spring, into summer, into fall, and back to winter again. The moon waxed and waned and waxed again. Life gave way to death, and from death came new life. Everywhere they looked, existence moved in circles, in rhythms of ending and renewal. And so it was the most natural thing in the world for ancient peoples, across many different cultures, to imagine that the cosmos itself must do the same, that the universe is born and grows and dies and is born again over and over in a great wheel of time turning forever. Some of the oldest spiritual traditions on Earth describe vast cosmic cycles, ages of the world that end and begin anew across spans of time so long they rival the numbers of modern cosmology. The dream of an eternal, cyclic universe is woven deep into the human imagination. For a long time, science seemed to point that way too. As we said, Einstein and many others first assumed the universe was eternal and unchanging, a cosmos that had simply always existed, with no need for a beginning. When the evidence for the expanding universe and the Big Bang arrived, it came as something of a shock, and not everyone welcomed it. Some scientists resisted the idea of a beginning quite fiercely. In the middle of the 20th century, a group of brilliant physicists proposed what they called the steady-state theory, a clever attempt to keep the universe eternal even while accepting that it was expanding. They suggested that as the galaxies flew apart, new matter was being created continuously in the gaps, just fast enough to keep the universe looking roughly the same forever, with no beginning and no end. It was an elegant idea, championed by serious scientists, and for a couple of decades it was a genuine rival to the Big Bang. In the end, the steady-state theory lost. The evidence, especially the discovery of that cosmic microwave background, the afterglow of the hot, early universe, pointed clearly to a universe that had a hot, dense beginning, and the steady-state picture faded away. The Big Bang won, and the idea of a cosmic beginning became the accepted view. But notice the deep, human current running underneath all of this. Again and again, when faced with the idea that everything simply started one day out of nothing, some of our finest minds have recoiled and reached instead for a universe that goes on forever. There is something in us that finds an absolute beginning unsatisfying, that wants to ask, and what came before that? And something that finds a kind of peace in the thought of an eternal cosmos, with no abrupt edge, no first moment hanging unexplained. Penrose's conformal cyclic cosmology is, in a sense, the latest and most sophisticated expression of that very old longing. It is the dream of the eternal universe, returning once more, this time dressed in the rigorous mathematics of black holes and relativity. And Penrose is far from alone in reaching for something beyond the Big Bang. His is one of several serious ideas that physicists have developed, each trying in its own way to peer past that wall, to ask what the beginning really was, or whether it was a beginning at all. It's worth gently meeting a few of them, because together they show just how unsettled this deepest of questions really is. One idea is called the Big Bounce, where Penrose's universe expands forever. This picture imagines something more like a heartbeat. Instead of beginning at a true singularity, that troubling point of infinite density where the equations break down, perhaps the universe was born from the collapse of an earlier universe that had grown old and fallen back in on itself. As that previous cosmos contracted, it grew denser and denser until, instead of crushing down to an impossible point, some deep effect of quantum gravity caused it to rebound, to bounce, and begin expanding again as our Big Bang. In this view, our universe is the latest breath in an endless rhythm of contraction and expansion, collapse and rebound, with each bounce a new beginning. Some physicists explore this using a framework called loop quantum cosmology, which hints that the dreaded singularity at the Big Bang might be replaced by exactly this kind of bounce. Another idea, sometimes called the cyclic or ekpyrotic model, comes from the strange world of string theory and imagines our universe as a vast membrane, a sheet of reality floating in a higher dimensional space alongside other such sheets. In this picture, the Big Bang was the moment two of these immense membranes collided, releasing a flood of energy across our entire universe at once. And then, over almost endless time, the membranes drift apart and slowly come together again, colliding once more in a new Big Bang, over and over, in an eternal cycle of cosmic collisions. It's a wild and beautiful vision, and like Penrose's, it tries to replace the lonely, unexplained beginning with an endless rhythm. And then there is perhaps the most mind-bending idea of all, eternal inflation and the multiverse. In this picture, the rapid expansion that may have powered our own Big Bang never truly stops everywhere at once. In some vast background space, it goes on inflating forever, and every so often a small region settles down and freezes out into a universe of its own Big Bang, its own cosmos, like a bubble forming in an endlessly boiling sea. Our entire universe, in this view, is just one bubble among countless others, each with its own beginning, all embedded in an eternally inflating reality that had no beginning at all. An infinity of universes forever blossoming, of which ours is a single, quiet example. Now, all of these ideas, Penrose's aeons, the bounce, the colliding membranes, the eternal bubbles, share something striking in common. And it's the thing I most want you to carry away from this part of our journey. Every one of them is an attempt by brilliant, serious people to answer the same ancient question. Was the Big Bang really the beginning, or is there something more, something before, something eternal? We do not yet know which, if any, of these ideas is correct. They may all be wrong. The truth may be something none of us has imagined yet. But the very fact that so many of our finest minds are reaching past the Big Bang tells you something important. That the question of the true beginning is wide open, far more open than the simple textbook story suggests, and that the universe may be a great deal stranger and a great deal older than 14 billion years. Let's return to Penrose's vision and ask a tender question about it. If a universe really did come before ours, what survived the crossing? When one eon dies and becomes the next, what passes through that strange boundary, and what is left behind forever? It's a question that matters, because it tells us how connected we really are to that lost cosmos. And the answer is humbling. Almost nothing material survives. The atoms of the previous universe do not carry over into ours. The stars, the planets, the molecules, none of it makes the crossing. By the time an eon reaches its end, remember, all of that has long since decayed and evaporated into light. There are no atoms left to pass on, so we are not, in any literal sense, made of the recycled stuff of the previous universe. Whatever the atoms in your body once were, they were forged in the stars of our own eon, not the last one. The matter does not survive. What survives is something far more subtle. Not stuff, but shape. Not substance, but pattern. The thing that crosses the boundary between eons is the geometry, the faint imprint of how energy was arranged, the gentle ripples of the gravitational field, the smooth, vast contours laid down by the dying universe. In Penrose's picture, the great events of the old universe, those colliding, evaporating black holes, would have sent gravitational ripples washing across the cosmos. And the echoes of those ripples, the patterns themselves, are what bleed through into the new eon. So, if anything of the previous universe reaches us, it reaches us not as matter, but as a kind of faint music, a pattern, a signal, the ghost of an arrangement, written into the very first light of our own cosmos. The dead universe leaves us not its body, but a whisper of its shape. And it's worth dreaming just for a moment about what that previous universe might have been like, because in Penrose's theory, every aeon obeys the very same laws of physics, the same gravity, the same kind of matter, the same rules that let gas collapse into stars and stars cluster into galaxies and heavy elements forge in stellar furnaces, which means the universe before ours would not have been some alien, unrecognizable place. It would have had stars, very much like our stars, galaxies, wheeling through the dark, very much like ours. It would have had its own long ages of light and warmth, and perhaps, though we can only wonder, it had its own worlds, circling its own suns. Perhaps it had its own oceans, its own weather, its own quiet blue planets. Perhaps, on one of those worlds, something looked up at its own night sky and wondered about its own beginning, never dreaming that its entire universe would one day fade to cold light and become the fiery dawn of a cosmos it would never see. A whole universe of stories, of beginnings and endings, of things that mattered, all of it gone now, all of it dissolved into the smooth and silent light that became our Big Bang. If Penrose is right, we are not the first, and we are built in the gentlest and most distant sense upon the grave of a world as full and as real as our own. Now, you might be wondering, if most scientists don't accept this idea, why should we spend a whole evening on it? Why give our attention to something that might well be wrong? And it's a fair question. But the history of science offers a gentle answer, and it's worth hearing, because it's easy to forget how often the boldest ideas have started out exactly where Penrose's stands now, on the fringe, doubted by the majority, waiting. Consider that the Big Bang itself, the very theory Penrose is now challenging, was once the radical outsider. When it was first proposed, many leading scientists found it absurd, even distasteful. The name Big Bang was actually coined by one of its fiercest critics, Fred Hoyle, a champion of that eternal, steady-state universe. And he meant it mockingly, as a way of belittling the idea. For years, the notion that the entire universe had a sudden beginning was treated by many as fringe speculation, almost an embarrassment. And yet, slowly, the evidence came in, and the mocked idea became the accepted truth. And today it's written in every textbook. The outsider became the establishment. Or think of the idea that the continents drift across the face of the Earth. When it was first proposed, it was ridiculed for decades. The notion that solid ground could slowly wander, that continents could split apart and drift across the globe, struck most scientists as obviously ridiculous. The man who proposed it died with his idea still rejected. And yet today, continental drift is the bedrock of how we understand our planet, taught to every schoolchild. The list goes on and on. Time and again, an idea that the experts dismissed turned out, in the end, to be right. And the lonely figure who proposed it was eventually vindicated, sometimes long after their death. This doesn't mean Penrose is right, of course. Most fringe ideas, it must be said, stay fringe for the simple reason that they're wrong, and conformal cyclic cosmology may well be one of them. Being an outsider is not the same as being correct, but it does mean we should hold our certainty loosely. The history of science is not a straight march of obvious truths. It is a long, winding story of bold guesses, fierce arguments, ideas mocked and then crowned, and the slow, patient work of finding out which dreams the universe actually agrees with. Roger Penrose has been right before, spectacularly right, when others doubted him. His black hole work was itself once far from mainstream. He has earned the right to be taken seriously, even when he stands nearly alone. And whether his cyclic universe turns out to be a profound truth or a beautiful mistake, there is something deeply admirable in a mind that, well into his 90s, is still gazing past the edge of the known, still refusing to accept that the beginning must simply be the beginning, still asking the oldest question of all, but what came before? Let's set the mathematics and the controversy aside for a while and simply feel what this idea would mean if it were true. Because beneath all the physics, conformal cyclic cosmology offers something to the human heart, a different way of holding the deepest fears we carry about endings. We are, all of us, creatures who struggle with endings. We know that things finish, that summers end, that people we love are lost, that we ourselves will one day come to an end. And on the largest scale, science has long offered a particularly cold comfort, about the fate of everything, that the universe is running down, heading toward that final heat death, that ultimate darkness and silence where nothing happens ever again. It can feel like the bleakest fact in all of science, that even the cosmos itself is mortal, that all this beauty is just a brief flicker between two eternities of nothing, and that the story ends in cold and dark forever. Penrose's idea gently turns that ending inside out. In his vision, the heat death is not the end of the story. It is the turning of a page, that final, perfect cold, that ultimate emptiness we so dread. It is not a tomb, it is a womb, the very moment that looks from the inside like the death of everything is, from the other side, the birth of everything all over again. The universe does not run down into permanent darkness. It runs down so completely that it forgets itself, and in that forgetting it begins anew, fresh and brilliant, and full of possibility, ready to make new stars, new galaxies, new worlds, new wanderers gazing up at new skies. Nothing is ever truly, finally lost. The ending is a doorway, and on the far side of the darkest night imaginable, there is always another dawn. There's a profound kind of peace available in that thought, and it's the same peace those ancient cyclic traditions reached for long ago. It is the peace of belonging to something that does not end, of being a small, brief part of a story that has no last page. We tend to feel the universe's mortality as a weight. But if Penrose is right, then existence itself is not a fragile, one-time accident soon to be snuffed out forever. It is an eternal, patient, endlessly renewing thing that has done this countless times before and will do it countless times again, blooming into light and fading into dark and blooming once more, forever and ever, world without end. We are not a flicker between two voids. We are one verse in a song that never stops being sung. And there's a strange tenderness in our place within it, too. We will never see the universe that came before us, only, perhaps, the faintest ghost of its shape in our ancient sky. And we will never see the universe that comes after us, though our own cold ending will, in the most distant future imaginable, become its first warm light. We are sealed inside our own aeon, our own single turn of the great wheel, able to glimpse neither the cosmos that gave rise to us, nor the one we will give rise to. And yet we are connected to both, threaded onto the same infinite chain, a single bright bead between an eternity behind and an eternity ahead. There is loneliness in that, but there is also a quiet, vast belonging. Our minds, it has to be said, are not really built for this. We are creatures of beginnings and endings. Every story we tell has a first page and a last. Every life we know starts with a birth and closes with a death. We crave the comfort of a starting point, a moment when things began, and the idea of something that has simply always existed, with no first moment ever, can make the mind feel as though it's slipping. Try for a second to genuinely picture it, time stretching back not just billions of years, but forever. No matter how far back you go, there is always more before. There is no first event, no opening scene, no moment when the lights came on for the very first time. because there was never a very first time. The chain of eons extends backward without beginning into an eternity that never started. It's almost impossible to truly hold that in your head, and that's all right. The discomfort you feel trying is not a sign that the idea is wrong. It may only be a sign that reality is bigger than the human imagination, which would not be surprising. After all, the alternative, the standard story, asks you to swallow something just as strange, that everything came from a single beginning, with absolutely nothing before it, time itself switching on out of no time at all. Both ideas break our intuition. Both ask us to stand at the edge of what a human mind can picture and peer into something it was never designed to grasp. Perhaps that's simply the price of asking the deepest question there is. The beginning of everything, whatever it truly was never going to be something that fit comfortably inside our small and local imaginations. So could we ever actually know? Could we ever find out whether Penrose is right? This is where the honesty of science matters most. For now, the answer is, we're not sure we can. The one place Penrose points to for evidence, those faint patterns in the cosmic microwave background, is being studied with ever more sensitive instruments, and as our maps of that ancient light grow sharper, we may eventually be able to say more clearly whether his Hawking points are really there, or whether they were only ever shapes we imagined in the noise, like faces in the clouds. Future telescopes and space missions, peering at that oldest light with greater and greater precision, might one day tip the balance one way or the other. There are also dreams of detecting the faint gravitational ripples from the early universe, which could carry their own clues about what came before. But it's entirely possible that the truth lies forever just beyond our reach, that the boundary between the eons is simply too well hidden, the signal too faint, the evidence too ambiguous, and that we will never know for certain what came before our Big Bang. And there's a kind of grace in sitting with that uncertainty rather than rushing to fill it. We don't have to know the answer tonight. We don't have to know it ever. Some questions are worth holding open, worth carrying gently, worth wondering about across a whole lifetime without ever demanding they be closed. Whether the universe began or has always been, whether we are the first cosmos or merely the latest of endless many, these are questions we get to live inside, not problems we are required to solve. And there is a deep and restful pleasure in that, in letting the great question simply be a question, vast and beautiful and unanswered, as you lie here in the dark. Let's try now to actually imagine the moment itself, the transition, the place where one universe becomes the next. It can't truly be pictured, of course, but the attempt is its own kind of meditation, and there's nothing more soothing than letting the mind drift across spans of time so vast they dissolve all our worries into nothing. Imagine the very, very end of an aeon. Not our aeon, the one before ours, say, or any of the countless ones strung along the infinite chain. The last star died so long ago that even the memory of starlight is gone. The last black hole evaporated in its final faint shimmer, an eternity past. What remains is almost perfect emptiness, a space grown so vast that any 2 points are unthinkably far apart, so cold that it hovers a hair above absolute zero, so quiet that nothing stirs. Drifting through this endless dark are the last photons, the final scraps of light, so stretched and so faint and so utterly alone that they almost aren't there at all. And there is no clock anywhere to mark the passing of time, no ruler to measure the immensity, nothing at all to say whether a single instant is passing or a trillion years. Time, in any meaningful sense, has stopped, not because it ended, but because there is nothing left for it to happen to. And in that frozen, scaleless, dreamlike state, something turns, not violently, not with a crash. There is no explosion, no drama, nothing that anyone could have watched, even if anyone had been left to watch. It is more like a quiet reinterpretation of what is already there. That vast, cold, smooth sea of light, having lost all sense of its own size, is, from another point of view, the point of view of what comes next, not vast and cold at all, but small and hot and dense and brimming with energy. The same exact reality, read at a different scale, becomes a Big Bang. The endless dead expanse, seen freshly, is a newborn fireball. And out of it, in the new eon, time begins to flow once more, and space begins to swell, and the first particles of matter condense out of the energy, and gravity begins, ever so gently, to gather them together. And in time, the new eon's time, the first stars of a brand new universe flicker into light, in a cosmos that has no memory whatsoever of the one that came before, no knowledge that it is not the first, no inkling that its own brilliant dawn was, on the other side, the quietest death imaginable. That is the moment Penrose asks us to imagine, the seamless, silent hinge between everything and everything again. The place where the end and the beginning are not two things, but one. And whether or not the universe truly works this way, there is something almost unbearably beautiful in the picture, the idea that the most final ending conceivable is also, in the same breath, the freshest beginning. That cold becomes fire, that death becomes birth, that emptiness becomes everything, not through violence, but simply through forgetting how to tell the difference. It's worth pausing to feel just how staggering the timescales are, because they put our own little lives into a perspective that is, somehow, more comforting than frightening. We've thrown around some numbers tonight: 14 billion years since our Big Bang, trillions of years for the last stars to die, and that almost unwritable span, A1 followed by 100 zeros, for the great black holes to evaporate. These numbers are so large that they stop meaning anything in the ordinary way. The entire history of the universe so far, all 14 billion years of it, every star that has ever shone, every galaxy that has ever turned, the whole long story from the Big Bang to this very moment, is, against the full lifespan of a single eon, less than the first faint second of a long day. We are living in the earliest morning of our universe, and even our universe's whole life is just one bead on a string that runs to infinity in both directions. And your life, your single human life, the few decades you'll walk beneath these stars, set against all of that, it's almost nothing at all. A flicker within a flicker within a flicker. It would be easy to find that thought crushing, But I gently offer you the opposite, because here you are, in the brief, warm morning of one universe among endless universes, somehow awake, somehow aware, somehow able to look up and wonder about the whole infinite chain of it. Out of an eternity of cold and dark and light, you get this. A handful of years in the rarest possible season, the season of stars and warmth and life, with eyes to see it and a mind to marvel at it. The universe spends almost all of eternity empty and dark. You happen to be alive in the tiny, precious window when it is full of light. That's not a small thing. That's the most extraordinary stroke of fortune imaginable. So when the scale of it all threatens to feel lonely or cold, you can turn it the other way. You are not lost in the vastness. You are the vastness, briefly woken up, briefly able to know itself. You are the universe, in its bright, young morning, looking back at where it came from and forward to where it's going, and wondering. And whether this is the first universe or the latest of countless many, whether time began or has always been, you are here for the part that matters most, the part with light in it, the part with you in it. And in a little while, you can let even that thought go and simply rest in the warmth of being one small, living spark in the long, bright morning of the world. There's a piece of the picture we haven't yet named, and it turns out to be the quiet engine that makes the whole cycle possible. It's something called dark energy, one of the strangest discoveries in all of modern science. Not so very long ago, scientists assumed that the expansion of the universe, set off by the Big Bang, would gradually slow down over time, with gravity gently pulling everything back, putting the brakes on. But when they actually measured it, in the late 1990s, they found the opposite, and it shocked them to their core. The expansion of the universe is not slowing down, it's speeding up. Something is pushing the galaxies apart, faster and faster, an unknown force woven into the fabric of empty space itself. We don't really know what it is, so we gave it a placeholder name, dark energy. And it appears to make up the majority of everything there is. For our story, dark energy is essential, because it is what guarantees the ending Penrose needs. A universe whose expansion is accelerating is a universe that will expand forever, without limit, growing ever emptier and colder and more dilute, with no possibility of ever falling back together. Dark energy is what drives the cosmos inexorably toward that final, vast, scale-free state of nothing but thinly scattered light, the very state that becomes the next Big Bang. Without dark energy, the cycle might never complete. With it, the ending is assured. So, the same mysterious force that, on the face of it, seems to doom the universe to an ever lonelier expansion is, in Penrose's vision, precisely the thing that carries it around to a new beginning. The agent of the universe's death is also the agent of its rebirth. Even our ignorance here is beautiful. We don't know what dark energy is, and yet it may be the very hinge on which eternity turns. And there's one more deep thread worth pulling, about order and disorder, and how the universe could possibly start fresh each time. Remember the puzzle of the perfectly ordered beginning. the mystery of why the Big Bang had such astonishingly low entropy. We said Penrose explains it by inheriting that order from the smooth death of the previous eon, but there's a subtlety. Over the life of a universe, entropy, disorder, only ever goes up. So how does a universe that has spent an eternity accumulating disorder hand off a clean, ordered, low entropy beginning to the next? Where does all that accumulated mess go? The answer, in Penrose's thinking, comes back to black holes, and to one of the most mind-bending ideas in physics. Black holes, it turns out, are where the universe hides its disorder. They are the great entropy sinks of the cosmos, swallowing matter and information and locking it away behind their horizons. And when those black holes finally evaporate over those unimaginable timescales, Penrose argues that the information, the disorder, the memory of everything that fell in is, in effect, erased, smoothed away, removed from the universe entirely. The black holes act like the universe's cleaners, gathering up the accumulated mess of an entire cosmic history, and, in their evaporation, quietly disposing of it. By the time the last black hole is gone, the universe has been wiped clean, smoothed back to that featureless, orderly, low-entropy state that can serve as a fresh beginning. It's as though, before each new dawn, the cosmos carefully erases all memory of the day before, so it can start the new one with a clean slate. The slate wiping is what makes the cycle possible. Now, a thoughtful person might ask, at this point, is this really science at all? Or is it something closer to philosophy, or even poetry, dressed up in the language of physics? And it's a fair and important question, one that gets to the heart of how science works. For an idea to count as truly scientific, in the usual view, it has to be testable. It has to make some prediction that we could, at least in principle, check against reality. Some way it could be shown to be wrong. An idea that can never, ever be tested, that makes no difference we could ever observe, sits outside of science, however beautiful it might be. And this is exactly why Penrose's claim about the cosmic microwave background matters so much beyond the specific patterns themselves, because it's his attempt to keep conformal cyclic cosmology on the scientific side of that line. By predicting that the previous eon should have left observable marks in our sky, he's giving the idea a way to be tested, a way to be proven wrong if the marks aren't there, or supported if they are. That's what separates his proposal from mere speculation. It's a genuine scientific hypothesis, making genuine predictions, even if those predictions are, so far, hotly disputed. Penrose isn't just telling a lovely story. He's sticking his neck out, betting that the universe will show us evidence, and inviting the world to check. That's science doing what science does, right at the ragged edge of the possible. But it's also true that we may be brushing up against the limits of what we can ever hope to test. And there's no shame in admitting that some of the grandest questions might sit forever in a kind of borderland, too profound to ignore, too distant to confirm, hovering somewhere between rigorous science and pure wonder. Perhaps that's where the very biggest questions are always destined to live. And perhaps that's all right. We can let an idea be both a serious scientific proposal we may one day test, and a beautiful piece of cosmic poetry to rest our minds against tonight. It doesn't have to be only one of those things. And here's something gently reassuring. The shape of Penrose's idea is one we already know in our bones because we see it everywhere. The universe, if he's right, breathes the same rhythm that everything around us breathes. Think of how much of the world moves in cycles. The water in the ocean rises as vapor, gathers into clouds, falls as rain, runs down rivers to the sea, and rises again, endlessly, the same water going around and around. The seasons turn and return. A forest grows and dies, and its fallen leaves feed the soil from which new trees rise. The carbon in your own body has been part of countless other living things across the ages, breathed out and taken in again and again in a great slow circle of life and death and life. Nature, at every scale we can see, loves a cycle. It rarely throws anything away for good. It takes endings and quietly turns them into beginnings over and over as its most basic habit. Penrose is simply suggesting that the universe as a whole does the same thing, that the grandest structure of all follows the same ancient rhythm as a raindrop or a falling leaf or a beating heart. There is something deeply right feeling about that, a cosmos that recycles itself the way everything else does, a universe that, like the world it contains, knows how to begin again. There's a quiet implication tucked inside all of this that's worth drawing out because it touches one of the most wondered about questions of all. Why is our universe the way it is? Our cosmos seems almost suspiciously well suited to existence. The strengths of its forces, the masses of its particles, the precise value of that dark energy. So many of the fundamental numbers that govern reality sit in a narrow range that allows atoms to form, stars to burn, chemistry to happen, and, eventually, life to arise. Nudge a few of those numbers even slightly, and you'd get a sterile, lifeless universe. No stars, no atoms, nothing. Why are the dials set just so? It's another of those deep, unanswered questions. In Penrose's picture, every ion runs on the very same laws, with the very same fundamental numbers, cycle after cycle, forever. So, in his vision, this isn't a one-time stroke of luck. It's simply the eternal character of reality, the same in every universe along the infinite chain. That's a different answer than some other theories give. In the multiverse picture, for instance, the numbers might vary from bubble to bubble, and we simply find ourselves in one of the rare universes where they happen to allow life, because of course, we couldn't exist in the ones that don't. Penrose's eternal cycle offers something steadier, not endless variation, but endless repetition of the same deep, life-permitting rules. Whether that's more or less satisfying is perhaps a matter of temperament, but it's worth seeing that the question of why we're here at all is woven right into these grand ideas about beginnings and endings, how the universe started and why it's the kind of place that could ever notice it started are really the same great mystery seen from two sides. And I want to gently hold space too for the very real possibility that Penrose is simply wrong, because even that wouldn't diminish the value of the journey we've taken tonight. It may turn out that the standard story is right after all, that the Big Bang really was the beginning, that time really did switch on in that first instant, that there was no before, and that the universe is a one-time event, blazing briefly and then fading toward a cold that is truly final. That picture has its own stark grandeur. There's a fierce kind of preciousness in the idea that all of this happened only once, that we are not one of endless many, but a singular, unrepeatable flash of existence, never to come again. If this is the only universe there will ever be, then every star, every sunrise, every face you love is rarer and more precious still, a thing that happened once in all of eternity and will never happen again. So whether the cosmos is eternal or unique, whether it cycles forever or blazes only this once, either way, the wonder holds. Either way, we are unspeakably fortunate to be here at all, in the light awake for our small turn. The two pictures point, in the end, toward the same gratitude. Think, for a moment, about that ancient light again, the cosmic microwave background, the place where Penrose goes looking for the ghost of the universe before ours. There is something almost unbearably poignant about it, quite apart from any theory. That faint glow has been traveling toward us for nearly 14 billion years. It set out when the universe was a glowing infant, long before there were stars or galaxies or planets or us. It has crossed almost the entire history of the cosmos to arrive tonight at the instruments we've built to catch it. When we look at that light, we are not looking at the present. We are looking as far back in time as light itself allows, at the baby universe, at the closest thing there is to a photograph of the beginning. It is the oldest thing we can see, and Penrose dares to ask whether, hidden in its faint and ancient patterns, there might be something older still, a message faint as a half-remembered dream from a time before the beginning. Whether or not that message is really there, simply to look at that light is to look almost all the way back to the edge of everything. We have, in a sense, found a way to see the dawn, and we get to lie here, in the dark, and know that the dawn is still arriving, still falling softly on the world all these billions of years later. So, let your mind rest in that for a while, as the night deepens. You don't have to decide tonight whether the universe is eternal or singular, whether it cycles or it doesn't, whether Penrose is a prophet or simply a beautiful dreamer. None of it asks anything of you. The great wheel, if it turns at all, turns on timescales so vast that nothing you do or feel or worry about could ever touch it. The eons will rise and fall, or the one universe will blaze and fade, entirely without your help, entirely without your concern. There is a deep permission to rest in that, a reminder that the largest things are utterly beyond our managing, and that this is not a burden but a release. You are not responsible for the fate of the cosmos. You are only asked for this one brief and luminous moment to be here, and to wonder, and then to let even the wondering go soft and quiet as you drift towards sleep. And there's a last gentle thought to carry down with you. If the universe really does know how to turn endings into beginnings, if even the death of everything is only a doorway to a new dawn, then perhaps there's a small comfort in that for all the smaller endings we live through. Every night, ends in a morning. Every winter loosens into spring. Every ending we've ever feared has, so far, been followed by something else, some new beginning we couldn't see from inside the dark. The universe may or may not be eternal, but the pattern it might follow, the turning of endings into beginnings, is one we can lean on in our own small lives, tonight and every night. The dark is not the end of the story, it never has been. It is only the part of the story where we rest. It's worth remembering how recently we learned any of this at all, because it puts Penrose's daring into perspective. For almost all of human history, we had no idea the universe was expanding, no idea it had a beginning, no inkling of its true age or scale. It was only about 100 years ago that an astronomer named Edwin Hubble, peering through one of the great telescopes of his day, made the discovery that changed everything. He found that the faint smudges of light we now call galaxies were not part of our own Milky Way, as many had assumed, but separate islands of stars, unimaginably far away. And then he noticed something even stranger. The light from those distant galaxies was shifted toward the red end of the spectrum, stretched out, in a way that revealed they were moving away from us. The farther away a galaxy was, the faster it was receding. This was the fingerprint of an expanding universe, the very clue that, run backward, leads to the Big Bang. In the space of a few years, our cosmos went from a single, possibly eternal galaxy to a vast and growing sea of billions of galaxies, all flying apart, all tracing back to a single, fiery dawn. It was one of the most profound shifts in perspective our species has ever undergone. And it's humbling to realize that we are still, even now, in the earliest days of understanding all this. We only confirmed the Big Bang's afterglow in the 1960s. We only discovered the accelerating expansion, the dark energy, in the 1990s, within the lifetime of many people alive today. We are like someone who has just woken up in an enormous, ancient house and is only beginning, room by room, to grasp how vast it is and how long it has stood. We've been doing serious cosmology for barely a century. It would be the height of arrogance to assume we already have the final answers about the beginning of everything. The story is still being written, and people like Penrose are the ones pressing into the unlit rooms, lantern in hand, asking what else might be there. And what a figure he is to be doing it. Roger Penrose has spent his long life as a kind of beautiful contrarian, a mind that delights in seeing what everyone else has missed. Beyond his Nobel-winning black hole work, he's known for inventing strange and gorgeous mathematical patterns, tilings that never quite repeat, shapes that seem to defy the rules, and for impossible figures like the famous endless staircase that inspired the artist Escher. He's thought deeply and controversially about consciousness, about the nature of mathematical truth, about the deepest foundations of reality. He has never been afraid to stand apart from the crowd, to follow his own strange intuitions even when his colleagues shook their heads. Some of those intuitions have turned out to be among the most important ideas of the century. Others may turn out to be lovely dead ends, but that willingness to keep thinking the unthinkable, to keep asking the forbidden question well into a long life, is its own kind of inspiration. There is something to admire in a person who never stops wondering, who reaches the very summit of their field and then keeps climbing off the map into the unknown, simply because the questions are too beautiful to leave alone. There's a deeper reason physicists are uneasy about the Big Bang as an absolute beginning, and it's worth understanding, because it's part of what drives people like Penrose to look beyond it. The problem is something called a singularity. When we run the expanding universe backward in our equations all the way to that first instant, the numbers don't just get very large, they blow up to infinity. The density becomes infinite. The temperature becomes infinite. The curvature of space and time becomes infinite. And in physics, when your equations start spitting out infinities, it's almost never a sign that something infinite is really happening. It's a sign that your theory has broken down, that you've pushed it past the edge of where it works, into territory it can no longer describe. The Big Bang singularity, that supposed first moment, is exactly such a place. It's not so much an answer as a question mark, a spot where our finest theory of gravity, Einstein's general relativity, simply throws up its hands and stops making sense. Penrose knows this territory better than almost anyone alive, because he spent his career studying the other place where the same thing happens, the heart of a black hole. There, too, the equations predict a singularity, a point of infinite density where space and time break down. In fact, it was Penrose who proved that such singularities are unavoidable when a star collapses. So when he looks at the Big Bang singularity, he sees something deeply familiar and deeply unsatisfying. He doesn't believe the universe really began in a true infinity any more than he believes matter really vanishes into an infinite point inside a black hole. He suspects that both of these singularities are signs that we're missing something, that there's a deeper layer of reality beyond our current theories where these infinities smooth away into something sensible. His conformal cyclic cosmology is, in part, an attempt to do exactly that for the Big Bang, to replace that troubling infinite beginning with a smooth, finite transition from a previous eon, to heal the singularity by connecting it to something that came before. He is not the only great mind who tried to soften that harsh beginning. His old collaborator, Stephen Hawking, took a completely different path to a strangely related destination. Hawking, working with others, proposed what's called the no-boundary idea, a subtle and beautiful suggestion that, very near the beginning, time behaves less like time and more like another dimension of space. And if that's so, then the Big Bang wasn't a sharp edge at all. There would be no first moment, no abrupt boundary where everything suddenly switched on, any more than there's a sharp edge or a first point at the south pole of the Earth. The beginning would be smooth and rounded, finite, but without a boundary. You could travel toward it, but you'd never reach a wall, a place where reality simply started. It's a very different idea from Penrose's cycles, but notice the shared instinct. Both of these towering physicists, looking at the raw Big Bang, felt that a hard, infinite, first moment beginning couldn't be the final truth. Both reached for something gentler underneath it. Hawking smoothed the edge into a seamless curve. Penrose connected it to an endless chain of universes. They disagreed, often sharply, about almost everything in this domain, but they agreed in their different ways, that the beginning was stranger and subtler than the simple story suggests. It can be soothing, in a strange way, to walk slowly through the great ages of the universe's future, the way you might trace a long road on a map before sleep. Scientists sometimes divide the immense future of the cosmos into eras, and laying them out end to end gives you a feel for the sheer scale of what Penrose's cycle has to traverse. We live, right now, in what's called the stelliferous era, the age of stars. It began a few 100 million years after the Big Bang, when the first stars lit up, and it will last until roughly 100 trillion years from now. It is the bright age, the age of starlight and warmth, and, at least on one small world, life. And as long as it sounds, 100 trillion years, it is only the opening chapter. After the last stars burn out comes what's called the degenerate era, a long, dim age lit only by the fading embers of dead stars, the white dwarfs slowly cooling, the faint glow of stellar corpses drifting in the dark. This era stretches on for a span of time so long it makes the age of stars look like a single afternoon. And during it, even matter itself may begin to come apart as the particles that make up ordinary stuff slowly decay over unfathomable stretches of time. Then comes the black hole era, when even those remnants are gone and black holes are essentially all that's left. The last significant objects in a cosmos otherwise emptied out, reigning over the darkness for a span of time, written with that staggering number, a 1 followed by 100 zeros, as they too slowly evaporate. And finally, after the last black hole has shimmered away into nothing, comes the dark era, the true heat death, the endless, featureless future of thinly scattered light and almost perfect emptiness, stretching on forever. Or, if Penrose is right, not forever at all, but only until that scaleless, light-filled emptiness quietly turns and becomes the brilliant first instant of a brand new everything. That's the road his cosmic cycle has to travel, from the bright morning of stars, through the long, dim afternoon of embers, into the black and silent night of evaporating giants, all the way to the perfect emptiness at the end, and then, somehow, around again to a new dawn. It is the grandest journey imaginable, and we are standing right at the very start of it, in the first golden light of the very first era, looking ahead at a future so vast it can barely be named. And underneath all of it lies a question even Penrose's beautiful cycle cannot fully answer. The deepest question there is. Even if the universe has always existed, even if it cycles forever with no first beginning, you can still ask, but why is there anything at all? Why is there a universe to cycle rather than simply nothing? No aeons, no light, no laws, no existence of any kind. An eternal universe pushes the question of the beginning infinitely far back, but it doesn't quite dissolve this deepest puzzle of all. Why something rather than nothing? It may be that this question lies forever beyond the reach of any theory, scientific or otherwise, that it is less a problem to be solved than a mystery to be stood before in silence. And there's something fitting about ending here, at the one question that humbles every theory equally. Whether the universe began or is eternal, whether it cycles or blazes only once, the sheer fact of its existence, the fact that there is something here to wonder about, and someone here to wonder, remains the quietest and most astonishing miracle of all. It's worth drawing one more gentle distinction because it clarifies just how different Penrose's vision is from the other great many universes idea you may have heard whispered about. When people talk about a multiverse, they usually mean universes existing alongside ours, parallel, simultaneous, countless other cosmoses spread out somewhere beyond our reach, all coexisting at once. Penrose's picture is not that. His universes don't sit side by side. They come one after another, in sequence, strung along an endless line of time. This eon, then the next, then the next, each one rising only after the last has died. It's the difference between a vast library of books all sitting on the shelf at the same moment and a single book being written page after page forever, with no first page and no last. The multiverse offers infinite universes in space. Penrose offers infinite universes in time. And there's something almost more intimate about his version. In an endless chain, our universe isn't just one of countless equals scattered across some larger reality. It's a single, irreplaceable link with a definite universe behind it that gave it life and a definite universe ahead that it will one day become. We have ancestors and descendants, in a sense, a lineage of cosmoses, and we are one generation in it. There's a strange warmth in that, a sense of belonging to a family tree of universes, rather than being lost in an infinite crowd of them. And perhaps that's the gift of spending an evening with an idea like this. Not the answer, which we don't have, but the shift in perspective, which we can keep. Because it's almost impossible to truly contemplate these vast spans of time, these endless cycles, these universes beyond universes, and not feel your own troubles grow quieter and lighter as you do. The worries that loomed so large this morning, the small frustrations of the day, the things that tightened your chest and crowded your thoughts, held up against 100 trillion years of starlight, against an infinite chain of cosmic dawns, they soften. They don't vanish. They still matter in the way that everything in a life matters, but they find their proportion. They settle into a gentler size. This is one of the oldest and kindest things the night sky has ever done for us. It takes the enormous, anxious weight of being a small creature with a busy mind, and it sets that weight down against something so much larger that, for a little while, you can simply rest. The universe is unimaginably old, and may be endless, and will carry on its slow, majestic turning long after every worry you have ever had is forgotten. And somehow, that isn't frightening. It's a relief. You are free to be small. You are free to let go. And here is perhaps the most wondrous twist in the whole story, the one that Penrose himself has spent much of his later life pondering. In this vast cosmos, whether it is eternal or singular, cyclic or one time, something utterly extraordinary has happened, at least here, on this one small world. The universe has produced something that can think about it, Out of the dust of dead stars gathered by gravity, warmed by sunlight, arranged over billions of years into the staggering complexity of a living brain, the cosmos has somehow grown a part of itself that can look back at the whole and wonder where it came from. You are that. When you contemplate the Big Bang, when you try to picture the end of time, when you let your mind reach toward an infinite chain of universes, the universe is, in a real and literal sense, trying to understand itself through you. The eons, if they exist, spent an unimaginable stretch of time as lifeless light and dust before, in one bright morning of one bright era, a little of that dust woke up and began to ask questions. Penrose has long been fascinated by this, by the deep mystery of how mere matter can give rise to a mind, to understanding, to the strange inner light of being aware. He suspects it's connected somehow to the deepest laws of physics in ways we don't yet grasp. And whether or not he's right about that, simply to notice it is to feel a kind of awe that has nothing to do with size or time. The universe is vast, almost beyond meaning. But the truly miraculous thing in it may not be its bigness at all. It may be the small, warm, improbable fact that here and there it has come alive and opened its eyes and started to wonder. Tonight, lying here, letting these great questions drift through your mind, you are one of those eyes. You are a place where the cosmos becomes aware of its own astonishing existence. That is no small thing to be, even for one quiet evening, even for the few minutes before sleep. So, as we drift toward the end of tonight's journey, let's gather the whole strange and beautiful idea back together and hold it one last time gently before we let it go. We began with a question so simple a child could ask it, and so deep that the greatest minds have never settled it. What came before the Big Bang? The usual answer is that there was no before, that time itself began in that first instant, and the question simply runs out, like asking what lies north of the North Pole. But one of the most brilliant physicists of our age, the Nobel laureate Roger Penrose, refuses that answer. He believes the Big Bang was not the beginning. He believes our universe was born from the death of a universe before it, and that ours, in turn, will one day become the dawn of another. And we followed his reasoning all the way to the end of time, past the death of the last star, past the slow evaporation of the last black hole, to a cosmos grown so vast and so empty that nothing remains but thinly scattered light. And we saw his astonishing insight that in a universe of nothing but light, with no mass to make clocks tick or rulers measure, the very idea of size and time dissolves, and that frozen, scaleless ending becomes mathematically indistinguishable from a hot, dense beginning. The end of one universe, having forgotten how to measure itself, simply becomes the Big Bang of the next, not by collapsing, not by bouncing, but by expanding so completely that its ending wraps around into a new beginning, an endless chain of universes, eons, he calls them, each rising from the ashes of the last, with no first page and no final one. We were honest about the doubts. We saw that most scientists aren't convinced, that the faint marks Penrose claims to see in the ancient light are disputed, that this remains a bold idea on the fringe, possibly wrong. But we also saw what it reaches for, an answer to why our beginning was so strangely perfect, a way past the lonely wall of the Big Bang, and a vision as old as humanity itself, the dream of a cosmos that turns, like everything we know, in endless cycles of ending and renewal. And maybe that's the thing to carry down into sleep with you, not whether it's true, but what it reaches toward. It reaches toward the idea that nothing is ever finally lost, that even the death of everything is only the turning of a page. It reaches toward the idea that endings and beginnings are not opposites, but the same moment, seen from two sides. It reaches toward the idea that we belong to something far older and far larger than a single universe, that we are one bright bead on a chain that runs to infinity in both directions. And it reaches toward the oldest and most human hope of all, that after every darkness there comes another dawn. Thank you for drifting through this one with me tonight, for following a single, impossible question all the way from a child's wondering to the end of time and back again, through black holes and dead stars and the faint ghost of a universe that may have come before our own. These are the best journeys to take slowly, in the dark, with the mind set loose to wander among the largest things there are. And I'm grateful you let yours wander out to the edge of the beginning with me. If these quiet explorations bring you some peace at the end of your day, take a moment to subscribe and stay with us so we can keep drifting out to places like this one together. There is always another question waiting in the dark, another beautiful mystery that turns out, when you hold it gently, to be less frightening than it is profound. For now, though, there is nothing left to do but rest. Let the great questions go quiet. Let the universe be as old or as young, as eternal or as singular as it truly is. It will be exactly what it is whether we solve it or not. And tonight, that is a comfort, not a worry. Picture it one last time, if you like. The cosmos, expanding gently into the dark, carrying its light outward across the eons, and far, far ahead, at the very end of everything, that cold and quiet ending softening, turning, becoming, without a sound, without a struggle, a new and brilliant dawn. The end becoming the beginning, the dark becoming the light, over and over, forever, world without end. And you, here, now, in the warm middle of it all, awake for your own small turn of the great wheel, with nothing to do but close your eyes and rest. The beginning is taken care of. The ending is taken care of. All you have to do is sleep. Good night.